Hello बच्चों. So in this problem we have been given a ladder of uniform mass distribution. It has length 5 meter. It is placed as shown and there is a coefficient of friction mu which is same for the wall and the floor. We have to find the minimum value of mu for ladder not to slip. So since we have to determine minimum value of mu, we will assume limiting friction at both these points. And for ladder to remain in equilibrium, we need to consider ट्रांसलेशनल एज वेल एज रोटेशनल इक्विलिब्रियम. सो देखिए कैसे इसको सॉल्व करेंगे. सो बेसिकली सपोज द नॉर्मल फोर्स बाय द फ्लोर इज n1 and since the tendency of ladder is to slip in this direction, so this point will have tendency to slip in left direction, so the friction will act in right direction. So let us say friction is F1. Similarly, the normal force by wall is N2 and the friction force by wall is F2 and the weight is W, which will act from the midpoint of the rod. Now we have considered the limiting friction. So F1 will be equal to mu N1 and F2 will be equal to mu N2. Now for translational equilibrium, forces must balance. So the horizontal force, these two forces must be equal. So F1 equal to N2, but F1 is equal to mu N1. So we get mu N1 equal to N2. So we have got the relation between N1 and N2. Now for vertical equilibrium, we can see that N1 and F2, they are in upward direction and W is in downward direction. So N1 plus F2, so F2 is mu N2. So N1 plus F2 equal to W. So this is basically mu N2. And at the place of N2, we can put mu N1. So from here we get N1 plus mu square N1 equal to W. So N1 comes out to be, so we can write it as N1 1 plus mu square and equal to W. Now we will consider rotational equilibrium. So for rotational equilibrium, if body is in rotational equilibrium, then net torque about any of the point must be 0. So हम किसी point के about torque calculate करें, torque 0 आना चाहिए, net torque 0 आना चाहिए. So it is best to calculate torque about point B because we have got relation for N1 and W. So we will calculate torque about point B, then these two forces will have 0 torque. And the torque of F1 can be given by F1 into 4. This is the moment arm. And this is W. So this length is given to be 3 meter. So basically this length, which is the moment arm, this length will be 3 by 2 meter. So the torque of W will be W into 3 by 2. So this weight as well as friction, they are trying to rotate the rod in anti-clockwise direction. And this normally trying to rotate the rod in clockwise direction. So the torque of N1 must balance the torque of W and torque of F1. So torque of N1 will be equal to, this length is 3. So N1 into 3, this is the torque of N1. Now at the place of, now we can cross multiply by 2. So we get 8F1 plus 3W equal to 6N1. So at the place of F1, we can substitute mu N1. And at the place of W, we can substitute N1 1 plus mu square. So from here we can cancel out N1. So we get this relation and a quadratic equation in terms of mu. Now by breaking this 8 mu into 9 mu minus mu, we can solve this quadratic equation to get value of mu as 1 by 3. So this is the answer. Thank you.